Today, we're going to learn how to deal with products and quotients of functions and how we take the derivatives. And let's start with an example here. So we have x squared times x cubed. So you might jump into this problem and say, okay, well, I know the derivative of x squared is 2x and the derivative of x cubed is 3x squared. And so I just multiply those together to get 6x cubed. Okay, hopefully you're not going to do that because hopefully by this point in time, I've ingrained into you that you should simplify before we deal with multiplication. But you might have tried that, but that's not going to be right. So let's think about what happens if we simplified this first and see if we get the same answer. So if we simplify this first, we add those exponents. So we get x to the fifth, and then we take the derivative. I'm going to write d over dx here to indicate I'm taking the derivative, and I get 5x to the fourth. So 5x to the fourth has to be the correct answer because I've simplified, I found the derivative. So that 6x cubed was not correct. The main reason of doing these two different methods for me here is to show you that if I have two functions multiplied by each other, I cannot just take their derivative separately and multiply them together. So in this one, we were able to simplify first. That won't be possible in every problem. Okay, if I had x times e to the x, there's no simplification that can be done. So we had to figure out how to deal with this. So let me do something a little funky and show you that we get the 5x to the fourth, and then this is going to be how this works in general. So what I'm going to do is I'm going to take the derivative of the x squared to get 2x, but I'm going to leave the x cubed alone. And then I'm going to add, this time I'm going to leave the x squared alone. Last time I took the derivative of it, and now I'm going to take the derivative of x cubed, which is 3x squared. Okay, this seems like a weird process, but I promise it'll work. So if I simplify this piece, I get 2x to the fourth. If I simplify this piece, I get 3x to the fourth. When I add 2x to the fourth plus 3x to the fourth, I get 5x to the fourth, which agrees with our derivative. So this is going to be how this works if I have a product of two functions. This is the product rule. What I'm going to do, and this is exactly what I have before here or down here, is I take the derivative of one piece, I leave the other piece alone. And then I leave the first piece alone, and I take the derivative of the other piece. Okay. And so that's how the product rule works. I don't memorize this in terms of F's and G's. I just think about how it works. Okay. So let's see if we can apply this. Once again, this is called the product rule. Okay. Ooh, so this one's going to make me take a second derivative. So the first derivative of this guy. So I have x squared times e to the x. There's multiplication there. This is not something I can simplify at all. So I have two different functions. I have x squared and I have e to the x. So I'm going to start out by taking the derivative of x squared, which is 2x. I'm going to leave the e to the x alone. And now I'm going to leave the x squared alone. I'm going to take the derivative of e to the x, which is just e to the x. But this one we're thinking of as a derivative. And I will leave my first derivative answer like that. This problem is making me take the second derivative. So now if I take the derivative of that, on this piece, I'm going to need a product rule because I have a 2x times an e to the x. So let me write this in blue. So the derivative of 2x is 2. I leave the e to the x alone. Then I leave the 2x alone. And I take the derivative of e to the x, which is e to the x. Okay, so that's the derivative of the first piece. Now I need the derivative of this piece. So I have an x squared times e to the x. The derivative of x squared is 2x. I leave the e to the x alone. Then I leave the x squared alone, and I take the derivative of e to the x, which is e to the x. So in this problem, we had to do the product rule both on this piece and on this piece. So we had a double product rule in here. I'm not going to try and simplify this. This is our final answer here. You could simplify that a little bit if you wanted. Okay, so this next one, there's actually two ways we could solve this problem. So this one I could have given you a few days ago. You could have simplified this first and then taken the derivative. You could have said this is square root of x plus 4x cubed root x. X squared is x to the 1/2. So we get x to the 1/2 plus 4 x cubed times x to the 1/2. 3 plus 1/2 is, what's that? 6/2 plus 1/2, 7/2. You guys get to see me do math in my head. That's fun. And so all I've done so far is simplify. Now I can take the derivative. I just have to do the product or the power rule here. There's no products here. So I would get 1/2 x to the negative 1/2 plus 4 times 7 halves, x to the, I subtract 1 from 7 halves, so that gives me 5 halves. Okay. So this is one way you could solve this. This is my preferred way to solve this. It's better to simplify it first. But you could also use the product rule on it. So if you use the product rule, you can leave it as it is. So this is my first piece, and this is my second piece. So if I'm going to use the product rule. Okay, so now I need to take the derivative of x, square root of x. Square root of x is x to the 1/2, so its derivative is 1/2 x to the negative 1/2. I leave the blue piece alone. I'm doing the product rule now. And then I leave the square root of x alone, and I take the derivative of the blue piece, which will be 12x squared. Okay, these two things will simplify and be equal to each other if we really wanted to simplify them. So both methods here are correct. We could use the product rule, or we could simplify. And you get to choose what you prefer. In the next video, we'll talk about what we do if we have quotients of things instead of products.